Hello viewers, welcome to my new channel. Today I am going to teach you Michelson interferometer. After that I will solve some previous year problems or problems of any book or any entrance exam questions regarding this theory. Let's start. We all know that interferometer is the instrument which is based on interference, and Michelson interferometer is developed by scientist Michelson. It uses the determination of wavelength of light, thickness of thin strips, refractive index. Let's understand its construction and the figure. In this figure, we can see that there is a source S, and light from the source falls on the lens L. Then parallel light falls on some glass plate which is semi-silvered. This is called beam splitter, or here I have named it G. From this beam splitter, the ray is divided into two types. The ray 1 goes to mirror 1, and the ray 2, it is transmitted through the glass plate and is transmitted towards mirror 2 M2. From mirror 1, the beam 1 is again reflected and passes through G and falls on a telescope. Same occurs in case of mirror 2. And here we have used an extra glass plate which is called compensating plate. This compensating plate compensates the extra path difference between the beam 1 and beam 2. Here I have written the construction. You can read it from the PDF, or in case of any doubt you can comment me. I will reply your comments. After reflecting from mirror 1 and mirror 2, the beam 1 and beam 2, they both interfere, and interference occurs. You can see the interference fringe in the telescope which is present below the figure. And in the telescope we can see three types of fringes. The first one is circular fringe. Remember, here I have considered the monochromatic fringe. Monochromatic light, sorry, not fringe, monochromatic light. That means sodium light, not white light. White light is polychromatic, and monochromatic means there is only one wavelength. And in this monochromatic light, we can see circular fringes. Here, if the mirror 1 and mirror 2 are exactly perpendicular to each other, means if the angle between mirror 1 and mirror 2 is 90 degree, here is mirror 1 and here is mirror 2. If this angle is 90 degree, then we can see circular fringes. Again, we can also see a virtual image of mirror 2 near M1. Just see, I am drawing the picture here. Yes, I have said that the glass plate G is semi-silvered. That means it both does the reflection and refraction phenomena. And when the mirror 2 is also seen in the glass plate, and its a virtual image is created near mirror 1. Sorry, here it's mirror 2 M2 dash, and the mirror 1 and mirror 2 may be parallel to each other, may they make some angle, or may they remain in straight line, anything can be. See about circular fringes. If the mirror 1 and mirror 2 and distance between them is d, then from source S, light falls on mirror 1 and mirror 2, that is S1 and S2, and they come back and interfere and forms interference pattern. And if we draw the, if we extend the sources 1 and 2, or we can say that beam 1 and 2, reflected beam from mirror 1 is beam 1, reflected beam from mirror 2 is beam 2, and if we extend them, they will go in this direction, and we can call them S1 and S2. Then we can see that from source S we got two virtual sources, S1 and S2, and the distance between S1 and S2 is 2d. You can learn it from previous theories or any standard books. If you don't know how the distance between S1 and S2 became 2d, then let me know in the comment section. I will make a different video on this. Now we will make a perpendicular from S1 to S2, and we can see that from this distance they have traveled equal path. And now in triangle S2 S1 S2 G, it is a right angle triangle, and S2G is 2d, and the angle S2G S1 is theta. Then we know that S2G by 2d equal to cos theta, and we can calculate the maxima and minima from this case. We know path difference. When the path difference between the becomes the odd multiple of wavelength, then it becomes minima. But we also know from Stokes law, that means path change in reflection. Here M2, the beam 2 is reflected from the glass plate G. That's why there is a path change between the two beams. That's why we can add or subtract pi phase or lambda by 2 wavelength. Let's proceed. From this we can calculate maxima and minima. When the mirror 1 and mirror 2 are exactly perpendicular to each other, then we can say that the mirror 1 and the virtual image of mirror 2, that is M2 dash, they will be parallel to each other. Here we have seen that in figure, if M1 and M2 are perpendicular to each other, then the virtual image of M2, that is M2 dash, will be parallel to M1. This fringe is called Heidinger fringe, or it is a circular fringe, or we can also call the fringes of equal inclination. There is a separate theory on Heidinger fringes. I have provided the notes in this video, but if you want a separate video, write in the comment section. And if in this case the Heidinger fringes, the distance d, that means the distance between M1 and virtual image of M2, that means M2 dash, is d, or that d is not equal to 0. If the distance between them is 0, that means if M1 and M2 dash lies in a line, then we can get physio fringe. Physio fringe is totally dark fringe, and we also call it fringes of equal thickness. Remember that Heidinger fringe is circular fringe, and we can see alternate patch of bright and dark circles. Yes, the central fringe is dark. How can we know that central fringe is dark? See, the maxima in this case is multiple of lambda by 2. If we take n minus 1 by 2 is some constant, or we can take half out of the bracket, then it will be some constant times lambda by 2. That means it is a odd multiple of lambda by 2, and we can say that this makes the central fringe dark, and alternate white and dark fringes can be seen. Then next comes localized fringes. If the mirror 1 and mirror 2 are not perpendicular to each other, they may cross in these three cases, and in these three cases we get different types of fringes. These are called localized fringes. If instead of monochromatic light we will use white light, then we will get colorful fringes. That means the central fringe will be definitely dark, but the after fringe thereafter the fringes will be colorful, and after 8 to 9 fringes we will get white fringes. Here the interference theory completes. In the next class we will see some consequences and uses of this interference theory. Thank you.